Let's take a look at this picture again. And this time, I add more details to it. What we just did in IntelliJ is we modified user service, user DAO. We add a new class called myUserPrincipal. In user service, we have our class implement an interface provided by Spring Security. It is user details service. And we have to implement a method called load user by username. In this method, we use userdao.findByUsername to retrieve this user from database. So we first find, and then we retrieve. DAO returns this user to service, but before we return this user to authentication provider, in this load user by username, we create an instance of this class, myUserPrincipal, and have it package our user. So user goes from database to DAO, from DAO to service, and then from service to myUserPrincipal. And we pass this instance of myUserPrincipal to authentication provider. The real authentication, that is comparing username and password, is really done in this authentication provider, not in here. So what we, the developers of our Spring Boot application, did is just to retrieve it, just to query this user from database. We are not responsible for authentication, which is good, right? Okay, so everything here is done. We still have to modify something in myUserPrincipal because, remember, this authentication provider will not talk to our user. It will talk to this myUserPrincipal because this class implements an interface provided by Spring Security called user details. So we have to make sure that myUserPrincipal will return the information needed by authentication provider. So that's our next task. When we finish this, we will make sure that this authentication provider knows the existence of user service, so it can pass username to this service to retrieve this user from database. So after we finish myUserPrincipal, we're going to come back to make our user service available in authentication provider. After the two steps, our Spring Security configuration will be done, and we're going to have a secured API application. So let's work on myUserPrincipal first. So we're going to make sure that this instance returns the information needed by this provider. Then we're going to work on making user service available in authentication provider. As I said before, myUserPrincipal implements an interface provided by Spring Security. And Spring Security will use those override methods, for example, get authorities, get password, get username, to retrieve the information needed for authentication. Right now, they're returning null. This is not acceptable. Okay, but remember, this is a wrapper class. This user is retrieved from database. So all the information like password, username is already here. So next, let's replace those null with user.get. All right, so password, user.get password. User.get username. Since we don't have account expired, account locked, so we simply just return true. Otherwise, authentication won't pass because it's expired or locked. So true, true, true. Our user does have enabled. So user dot is enabled. Okay, so those are easy. What about authorities? Now, if you remember, so let's go to our data initializer here. We do have roles, admin, user, and user. But right now, those are strings. But what we need here is something called granted authority. This is also a class from Spring Security. So what should we return? Okay, so here is what I do. For each user, based on its role, for example, like admin or user, we're going to create authorizations and put it there. So here is the syntax. To save time, I have already copied it on my clipboard. So what we're going to do here is, so besides this user, I'm going to create a list of authorities. As you can see, granted authority is also a class from Spring Framework.security. Okay, and return this authority. But right now, this is empty, right? So we have to populate it based on the roles of the user. So here is the syntax. Okay, so here is quite long. I have to import those. Collectors from Java util stream, good. All right. Also import arrays. Okay, so let me explain this a little bit. It's very long, so let me break it out. Okay, so here I'm using the new feature in Java 8, arrays.stream, okay, because stream is a very important API introduced to Java 8. Well, of course you can do this in for loop, but here I'm just chaining everything together in one statement. I'm doing a lot of things at once. So basically what I mean here is this.user.getRoles. Remember, if you take a look at this method, as you can see, so getRoles returns roles as a string. Well, this is my initial design. This may be oversimplified. That is, we can do something like this. User, I don't know, headmaster, or so on and so forth. So to make it easy, okay, this is a really easy, dirty way to implement a authorization system, is I want to use comma to separate different roles that one user can take. So if we get roles, we're really getting a string of comma separated roles. But in this simple example, I only have one row. Okay, just in case we have 2 or 3 rows separated by comma, here is the code that we separate them out. Okay, so split based on comma. So for each role, for example, admin or headmaster, we're going to create a new instance of simple granted authority. This is also from Spring Security. Okay, create an instance of this authority, and then we're going to collect them together, add them to a list, and there we go. Now, this one looks fancy, but it's easy to use for loop and new inside the for loop to get it done. Okay, this is just some fancy feature. You don't have to use this. Okay, just want to make sure that you guys understand what it means. All right, that's it. Okay, next we're going to do our second task, which is make our user service available in Spring Security. Okay, so let me close this, close this, close this. So how do we make our user service available? We need to inject it into the current config class. So private user service, and then we're going to use constructor argument to inject. This one. Good. All right. So now we make it available in the current class. How do we let Spring Security know that Spring Security can use this user service to load user by username? We need to override the second config method. Now remember, I said there are 2 config methods in Web Security Configure adapter. So this is the first one. Let's override the second one. Config authentication manager builder. That's the one. Okay. And all we need to do is one line. Auth dot user details service. Okay, then we're going to pass our user service. Okay, this guy here, to this method. So basically what I mean here is we're going to let Spring Security, or for example, in this picture here, the Spring Security authentication provider knows the existence of user service. So once it gets a request with username, it will pass it to this guy, and this guy will take it out from database and where we can do authentication here. All right, let's go back. Let Spring Security know how to retrieve user info from database. Okay, by the way, you don't have to have a database, okay? Sometimes you can save your user information in maybe a local file, or maybe you can request it from a different server. So the whole point is you're gonna let Spring Security know how to retrieve user info from your system. Maybe that's a better expression. Okay, one more thing we need to do before we finish. That is, Spring Security requires a password encoder. Now remember, never, never, never store plain text password in your database. Okay, you have to use an encoder to encrypt your plain password and then save it there. So this is easy because Spring Security comes with actually many password encoder. And one of the best, and my favorite, is called bcrypt password. So public bcrypt password encoder, and this is called password encoder. Return new encoder. Okay, then we're gonna let Spring take over the lifecycle of this instance. In other words, treat it as a bean. Okay, so when Spring is run, line 27 to 30 will be executed, and the returned encoder will be treated as a bean, and it will live in Spring context or Spring container. Whoever needs it, Spring will inject it in there. Well, actually, let's use it. Now remember, in our data initializer, right here, okay, here I set password. Those are not real password. Those are encrypted ones, okay? You may wonder how I get those encrypted password. Okay, actually, when you populate your database, you don't really put the encrypted password. You put plain password, okay? Set password to 1, 2, 3, 4, 5, 6. And I think this one is 6, 5, 4, 3, 2, 1. And the last one is also a very popular password, okay? Well, if you do this, then those plain passwords will be saved directly in database. We do not want those, okay? So what I'm gonna do here is, instead of using user DAO, I'm using user service dot save. User 1, 2, and 3. Well, I haven't inject user service here, so let's scroll up. We're not gonna use user DAO, but using private user service. Okay, let's delete this constructor and let IntelliJ create everything for us. Okay, so now I have injected user service. So we can use service to persist the 3 users. Then let's go to the save method in user service. Okay, as you can see right now, the service is using userdao.save. Okay, if you're not doing anything, the plain password will be saved. However, what I want to do is, before line 33, on line 32, I'm going to use the bcrypt encoder to encode my password. Then I will save the encoded user into database. Okay, but before that, we need to inject the encoder in service. So private bcrypt, let's just call it encoder. All right, then delete constructor, create this constructor for me. All right, so after we inject encoder, we can use encoder.encode, okay, right here. All right, line 35, user.set password, encoder.encode. And we're gonna put the plain password, 1, 2, 3, 4, 5, 6, right? So user.get password. All right, so after line 35, 1, 2, 3, 4, 5, 6 becomes, that very long encrypted password. Then we can save it, okay? We can save it. So remember, if you're going to save your user, okay, username, password, make sure that on the service layer, it's important to know it's on the service layer. Service is responsible for encrypting. DAO is only responsible for save, CRUD. So we're trying to do separate of concerns, okay? All right, close this, we're done. So next, let's run it and we're gonna test. So let me launch it. Okay, we get some problems. Let's take a look. Okay, so this kind of error is very common. remember we have a lot of dependencies. But if the dependencies form a circle, then that's really bad. Okay, so it looks like Spring Security, this guy here, depends on user service. That's for sure, because in here we inject user service. And for some reason, user service is also depending on config. All right, so let's go to user service. And it only depends on 2. Oh, this one. Okay, so this encoder is actually in here. So let's take a look. This encoder. Okay, I see. All right. So there are several ways you can solve this problem. First way is we can move this bin out of this class. Okay, so if we do cut, okay, we're not gonna register this bin here. We can do it in just like the ID worker. We go to the main class. In this case, here, double click. Okay, now this will solve the problem. This will solve the problem because then user service will no longer depend on this guy. Okay, it will depend on the main class. Okay, since the main class is not depending on anything else, this is a safe place to put all the bins. Okay, however, this will kind of make it unorganized, right? Because really this encoder belongs to Spring Security config. So let's cut. So that's one solution. It will work, okay? But let's put it back. All right. So let me show you another way that we can do this. All right. Let me delete this. Because up until now, we have been using constructor argument to inject. As I said before, I really recommend to do this. But in fact, there are actually the second way to inject dependency into this class. And that can help solve this kind of circular dependency problem. That is, we can simply just using the annotation called @AutoWired. Okay, now it gave me some warning. It says field injection is not recommended. All right. I mean, it's okay. This is just a warning. It's not recommended because this is a private and Java is using something called reflection to inject, which kind of violates the purpose of private. Okay. So let's use this. Let's use setter. Okay. Setter. Okay. And we're going to add this annotation to here. Okay, now it's happy. So this time we're not using constructor to inject. We're using setter to inject. Does that make sense? Because the whole point of injection is if Spring, the context, has a way to set an instance of this user service into here, that'll be fine. So constructor argument is good. Setter is also a good way to do it. Okay, or you can just add this annotation to add private to this field and use Java reflection to do it. But remember that is not recommended. So I think this will solve the problem. Okay, this is really equivalent to the constructor injection. However, it will solve this kind of circular dependency problem. Okay. All right. So let's run it again, and hopefully it will be gone. Okay. Okay. Then there's no problem. All right. No problem. Okay. So let's test. This is a really good point here. Just remember, if you see a circular dependency, and is it possible that it is caused by this constructor injection problem? Okay, if you change it to setter, it still doesn't work then that's a real serious problem. But this can solve it. Good. All right, so let's test. Let's go to Postman. So first, let's test find all artifacts. It should be any problem. I haven't logged in yet, so send. No problem. Find all wizards, no problem. Find all users, I got a problem, right? Then let's log in. So let me define a new login request. Okay, so it's post localhost 8080 users. Remember the URL is login, and also we have to pass something to the server side. Okay, in body, remember this is the form data. Okay, username is equal to John. Remember John. Okay, and then password is 123456. When user submit username and password, the password is in plain text. The server side needs to encode it, right? Okay, so this time we're going to send. All right, now since my previous request is find users, okay, so Postman remembers that I want to log in, and then after I log in, it find all users, as you can see here. Okay, all users. So that means our authentication works. Next, let's use a different user to log in. Like I say, Eric. Remember Eric? And his password is reverse 654321 and log in. Okay, so it's logged in, but since we do not have a success page, so that's why it's 404. It's logged in. As you can see, it's logged in. So let's do this again. Find our user. Right now, I'm logged in as Eric. So if I send, as you can see, as Eric, you also can see all those users. Okay, now we're Eric, right? Remember, Eric is a user. It's just a regular user. So let me show it again. Here, Eric's role is just a user. So now we're trying to delete, for example, John. Okay, John has ID 4. So let's go to H2 database. So make sure you know which ID is correct. So connect user. Okay, so right now we're Eric, and our role is user. We want to, let's say we're going to delete user 4. Okay, let's see if we can delete or not. Remember, in our settings, right here, in our settings, if you are going to delete somebody, this user must log in first, that's for sure. Also has authority admin. In this case, only John can delete other users. But now I'm Eric, I cannot delete, but I'm trying to delete. So we're trying to test if it works. Okay, so let's go to delete. Delete user by ID here, right here. Okay, right now I'm in the same session, so I'm logged in as Eric. I'm trying to delete user with ID 4, which is John, right? So send. As you can see, we got 4.3. 4.3 is forbidden, not enough authorization. Okay, next, let's test. We're gonna log in as John, and we're trying to delete Eric, right? So John is trying to retaliate. Okay, all right, so here, I'll change this to John, because John is the admin. 1, 2, 3, 4, 5, 6. Send. Okay, it is still 404. This is simply because we haven't defined the success page. Now this time, now remember I logged in, I'm in the same session, I'm John. I'm trying to delete Eric. Now Eric is number 5, if I remember correctly. Eric ID is 5, good. Postman and delete. All right, delete success, okay, delete success. So let's go to this page and refresh. As you can see, we only have John and Tom. All right, so that's a long journey, right? So security is not that easy. It can be more fine-grained, but here I just make it very coarse-grade authentication. Sprint security usually have a kind of steep learning curve, so I highly recommend you read the link that I provide in lecture note. Understanding what happened behind the scene can help you customize those authentication providers. Okay, of course, in most cases, the default providers or filters in Sprint security will be enough. But Sprint security also provides opportunities that you can customize their authentication. Okay, in the end, let's commit and push to remote repo on GitHub. First, add them to staging area. Then commit. Login down, close issue number 5. Okay, then we're going to push. Okay. Let's go to GitHub. So there's one open. Hogwarts. Okay, so we got to log in here, and we're going to compare and pull request. Able to merge. All right, remember, it's always recommended to assign reviewers. So create pull request. Merge. Confirm merge. All right. Then it's clean. There aren't any open issues. That makes my day. That's the best sentence that I like on GitHub. There aren't any open issues. All right. So now our master already has this login feature. Okay. So let's go to IntelliJ, and we're going to switch to master. Git pull. Okay. Now our master is in sync with the remote master.